So one more special case to look at here when we're using the y-intercept method. Remember that usually we see things like y equals mx plus c, and we can either go from a graph and write the rule, or have a rule and plot the graph. But there are the special cases of the vertical and horizontal lines. Again, vertical up and down, horizontal left to right. Now, two things that you need to remember. The vertical always has an x, and the horizontal always has the y. Which seems kind of counterintuitive, because the vertical axis is the y-axis, and the horizontal axis is the x-axis. But we have to use the x-axis to talk about vertical lines, and we have to use the y-axis to talk about horizontal lines. So watch how that's kind of confused for some people. Now, what it means here is that for a vertical line, the value of x never changes. And that's why we say that x is equal to something, because it really doesn't matter what y is. X will always stay the same for a vertical line, because it's not moving to the left or right at all. And that's the same for the horizontals. We don't care what the x is equal to anywhere along it, because the y never changes. The y is always the same. The line will never move up and down, up or down. So here, looking at the black line, this is a horizontal line. And what would we say never changes along here? X can change along this point, along the line. For instance, that's the point 4, 4. But this is the point 2, 4. And this is the point -5, 4. So the thing that's the same in all of those points is the y equals 4, which is why we call it y equals 4. Similar for the red line down here. It's another horizontal line, and I'm noticing that the value of y never changes. It's always a value of -2 anywhere along that line. So here I would say y is equal to -2. For the vertical lines, again, it's the value of x in this case that never changes, because the line never moves to the left or to the right. Any point along it is always going to have an x of -3 in this case. For instance, that's -3, -4. And this point here would be -3, -1. And this would be -3, 5. The thing that's not changing is the -3 in every single one of those points. And that's an x of -3, so we would say x is equal to -3. For the green line, this one again is a vertical line, so I'm imagining here that x will never change anywhere we go along it. So I can define it by saying x is always equal to 1. Anywhere on that line, x will be equal to 1. Just like anywhere on this line, x is equal to -3. So just be really careful to make sure you get your x and your y straight for vertical and horizontal lines, and from there it's pretty easy.